All right, this is help with 3.4, and this is the present value. That's what PV stands for, of an annuity. We're also looking at purchasing things and what would be the payment. And amortization is like when you buy a house, looking at how much money goes to interest and how much money goes to paying off your actual loan every single month. So those are the main ideas. So if we look at this first formula, this is saying present value of an annuity, okay, ordinary annuity. So present value is kind of like the idea of what would, if I make all these payments and over all this time, what would the current value be of that investment? So what would it be worth today? Okay. So then if we look down, we have to calculate a payment for debt. So remember, annuity is in a sinking fund, right? They're similar. Like you're putting money away to save. So if I'm asking anything with the word annuity, I'm not using this formula right here. Okay. This is for debt. I bought a car. I bought a house. What is my current payment? Okay. It kind of goes over all the different what each thing stands for again, PMT, payment right here. PV is present value of that item. So right now, if I bought a car for 20,000, my present value of the car is 20,000. When I purchase it and I drive off and now it's worth 10, pretty close though. Okay, and then we should recognize the R over N. That's our rate and our number of payments per year. Typically, N is 12. You usually make monthly payments, maybe quarterly for taxes. Maybe you might see some other things, but and then the rest of these are the same numbers over and over. Okay, so then this is just helping you remember how to get your interest. So it's saying your number of payments minus your present value. I'll show you that. It's basically like, well, if I make monthly payments and each payment is $300, 300 times 12 is how much I pay per year. And then I can get my contribution, and then that'll help you figure out with the present value, subtracting the present value off what the interest would be. Okay, if part or all of your price of your item is paid off with your periodic payments, then to calculate the cash value of the item would be, so cash value, present value of payments plus the down payment plus the trade-in. So that's how much it's worth, or cash value. I don't know if we go over that too much, but maybe a little. This one says to round to the nearest dollar, either way. So let's look at what Sam's doing here. Sam makes a deal to pay $500 a month for 4 years on a car loan at 2.9% annual interest compounded monthly to pay for his car. So what is his current present value of that car? So we don't know how much that car's worth right now. We just know the payment. So I walk into the dealership and they're like, you're going to pay $500 a month for 4 years at this rate. What are they saying that car is actually worth right now? If that car blue books at 13,000 and you do this present value formula at 20,000, you're not getting a deal. So it helps you when someone gives you a payment to come and be like, well, what's it going to be? So it's like adding up all of your payments for you. So part A, I'll do it down here just because I need a little more room to write with this Apple Pen. So we're going to do our present value is worth our payment of $500 times big fraction again. And then up here, it's 1 minus, and then it's 1 plus our rate of 0.029, and this is monthly, so we're going to divide by 12 to the power of a negative 12 times 4. If you're using a TI calculator, make sure you're using that negative next to the enter here in that exponent. Okay. And then we're dividing it by the R over N, so that's our 0.029 divided by 12. And again, you're going to want a parenthesis here, and then there is a parenthesis here that kind of ends. So there we go. So you can type it in just like you see, like this, just like I see it. So I'm going to go, okay, 500 times parenthesis 1 minus parenthesis 1 plus 0.029 divided by 12 to the power of negative 12 times 4. And some of your calculators, you're going to need the parenthesis there as well. Okay, around that exponent. And end your parenthesis around that whole thing, divided by another parenthesis, 0.029 divided by 12. If you don't put all those parentheses in, you don't end up with the right answer. So the present value is $22,634.51. Or you can round to the nearest dollar like the directions said. I always go cents. I don't know why the directions say to the nearest dollar. Usually it's to cent. Okay, so I walk into the dealership. They tell me my payments are $500 a month, and they gave me this 4 years at this rate. I'm paying $22,000-ish, for that car. Is it worth that? Maybe it is. Maybe it's only worth $10,000 and you're not getting a good deal. It's important to be able to calculate what the current value is of something based off payments. Okay, part B. How much will Sam make in payments? So he is making a $500 a month payment every month for 4 years. So it's always P times N times time. Okay, this is his contribution. Okay, so what is 500 times 12 times 4? He put in 24,000. Okay, so B is 24,000. Why is that more? Because this is an estimation of what that car is worth. Okay, so he would pay in 24,000. How much interest is he going to pay on this loan? So then I would take my 24,000, and I would then subtract off the $22,634.51. Because the 22,000 doesn't include the interest. It's just how much this car's worth. So you do have to pay the interest, 22,634.51. So I'm paying $1,365.49. I'm paying that much in interest. So you're always going to pay a little more than it's worth. We know that's the way it's going to be, right? But can you see why I have this formula? Okay. The next question is exactly the same. This note packet is huge. It has a lot of questions. So let's look at problem 3. A car dealer figuring interest at 4.9% compounded monthly offers to sell you a new car if you trade in your car that's worth $8,000 and agree to pay $400 every month for the next 3 years. Is this a good deal? How are we going to figure this out? What we're going to do is, and it asks, what is the I thought that was on highlighter. Oops. It's asking, what is the cash value of this car today? And the way that we're going to figure out that cash value is we're going to take the present value and add the 8,000. So the down payment, not down payment, well, kind of a down payment, right? The trade-in value. Down payments for a house usually, I mean, you could do a down payment on a car too, but he didn't. He traded in something, so he gets that 8,000. So it's still calculated pretty similar. I got to figure out that present value right now, and then I can add that 8,000 to that. So let's do that down here. The formula says take your payment, so present value is $400, and then times that by 1 minus 1 plus, our rate is 0.049. Is this monthly? Yep, monthly. So 12 to the power of negative 12 times 3 years. And then in that parenthesis over 0.049 divided by 12, parenthesis here, maybe a parenthesis here. And then we're going to add the 8,000 on this. So you could write it on there, I mean, just so we don't forget it, but we did write it up here showing we have to find that present value plus 8,000. So I'm going to figure out just the present value real quick. So 400 times 1 minus the parenthesis 1 plus 0.049 divided by 12 to the power of negative 12 times, oops, I did plus times 3. Okay, parenthesis divided by so many parentheses, 0.049 divided by 12. Whoosh. All right, I get $13,366.29 plus the 8,000, just so you can get that number on yours and make sure you get it correct, is $21,366.29. Oh, I moved it with my 29 cents here. There we go. The scroll bar. I hit the scroll bar and it went flying somewhere. Okay, so there we are. So what's the cash value right now? 21,000. So what are you going to compare your $21,366 to? What that car is worth, right? Because I'm going to be making $400 a month payments plus the 8,000, and I am really going to pay about this much. It's worth about this much money. Okay, part B says, how much total interest are you going to pay with this deal? All right, so interest again is, so we have to look at my contributions will be, so my contribution is going to be $400 for payment times 12 times 3. What is that? 12. Okay, I got to do that. 4 times 12 times 3. 400 is $14,400. So $14,400 is my contribution. So then we can minus off. Why are we, okay, so we are not including this because we don't pay interest on the 8,000. We're trading in a car. We only pay interest on that financed amount here. So this is the number that you're going to take off of the 14,000. So 14,400 minus the $13,366.29. Boo, 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 13,366.29. $1,033.71 is your interest. That's not that bad. Okay. Question 4 again is the same. I'm not sure why some of my note packets are like, those are from the company. Some of them have like not enough problems, and then this one has like a lot of problems. 2 to 3 of each idea. So problem 5, let me look at what that's asking. Mark and Natalie want to buy a house selling for, yeah, let's do a house for sure. They will put 20,000 down and they will finance. So what's it called when I buy a house and I have to borrow money? It's called a mortgage, right? So if you ever hear the word mortgage, it's just a loan for your house. So Mark and Natalie want to buy a house. I wish you could buy a house for 120,000, but not anymore, or at least not here. They will put 20,000 down as a down payment, and they will finance 100,000. If the bank offers a 30-year mortgage at 5.4%, oh, that's a huge rate. So unrealistic here and unrealistic here, to be honest with you. Houses aren't 120,000 right now, and your rates are around 2 to 3%. So really good rates, but really high prices. What's your monthly payment? So we have to use the payment formula. So payment was equal to present value times our R over N times, these are all times, our 1 minus 1 plus R over N to the power of negative N to the T to the minus 1. Okay. Like this. And or do I have room to write this? Ooh, I'm going to write it a different way, but I'll have to erase it. So we could write this like this. This is the way you might see it in a different book, times the R over N, and then 1 minus 1 plus the R over N to the negative NT. And like this. So a negative exponent means move it downstairs. So to me, the second one here is easier to follow. Take a second, write it down, pause my video if you want that. I'm going to have to erase it to fill in the numbers, but I kind of like this version better than this version because I don't like that you have to have this extra parenthesis to the negative one. Okay, so I have to erase this all to have room to actually do the problem, so I apologize, but it is what it is. Okay, so then it always leaves my words, which is kind of nice of it. Okay, so then we're going to put those numbers in. So our payment, this is part A, is going to equal our, how much are we actually financing? We're financing 100,000. Okay, and then we have times, I'll do my what I call prettier version here, 0.054 divided by 12, because this is monthly again, over our 1 minus the 1 plus the 0.054 divided by 12 to the power of negative, is it a 30-year loan? Yeah, 30-year loan, and we are compounding 12 for monthly, and then 30-year loan there, and this big parenthesis, and then parenthesis here. So put it in like this. It'll just be easier than that weird negative one. I'm not really even sure why they think that's easier, but I don't know. So 100,000 times parenthesis 0.054 divided by 12, end the parenthesis, divided by 1 minus 1 plus 0.054 divided by 12 to the power of negative 12 times 30. Oh my goodness, that's so much typing. And then end the denominator's parenthesis. I got a payment of $561. Okay, so oops, payment. Typically, they might round this to the nearest dollar, which would be 2, because otherwise you won't quite get to the right amount there. So let me fix that. It didn't look right. So it on the calculator, it's 561.53 cents, and it might make you do 54 cents to actually get to your goal. Okay, you have to round up. Some textbooks don't make you round up because they aren't really teaching you the right way, in my opinion. So you should have to round up 1 cent, up a cent. Okay, so you actually get to the right payment. Okay, or the right amount. So you don't have 31 years in your 31 year. So there's our payment. Approximately how much interest will they pay if they make all their loan payments on time? So my contribution again will be my payment of $562 every single month for 30 years. This is my contribution. So 562 times 12 times 30 is $202,320. All right, I contributed this much money. The house is worth this much money. So I can take 202,320 minus the 100,000 that it was worth when I bought it. And that's my interest. The interest is more money. Interest is more money than the house cost. Isn't that nuts? You're paying interest for 30 years. Huge interest. Okay. All right, let's see here. Okay, I'm gonna pause the video and you're gonna have a second one to finish.